Okay, so in 3.1, we left talking about filling in our radians for our unit circle. So I paused and we filled in those radian values, right? So now our unit circles are completed, correct? We now have the degrees, the radians, and the ordered pairs for each one. And the ordered pairs represents the cosine and the sine at every single point. Does that make sense? All right, so if you have your unit circle, go ahead and take it out for me. No, we did that. I know, we're about to use it. We did that yesterday. We did. We filled in our units, the rest of our unit circle yesterday. Like you already have your unit circle, and then we filled in the rest of it. All right. So with our unit circle, if I asked you for the tan of 2 pi over 3, you're going to go to 2 pi over 3. Did we find 2 pi over 3? Okay. At 2 pi over 3, you have ordered pairs, correct? In quadrant 2. Oh, in radians. Okay. In radians, do we see 2 pi over 3? All right. So 2 pi over 3 equals what degrees? 120. Agree? Okay. Huh? Yeah, we found it. Perfect. All right. So now to find your tangent. Your tangent means you're taking your y and dividing by your x. Do you remember that rule from unit 1? Tan is your y over your x. What is our y? Square root of 3 over 2. And what is our x? And negative 1/2. And if I divide those two, I end up with, right? Okay. So tangent means you're taking your y and dividing by your x. The y value at 120 is square root of 3 over 2. And your x is negative 1/2. When I divide these two, remember it's keep, change, split. Your 2's are going to do what? Cancel out, and all you're left with is negative square root of 3. Yes? Okay, so in unit 1, let's recall what we learned. So we learned that cosine equals your x, sine equals the y value, tan equals your y over x, and then of course they're reciprocals, right? So now keeping that in mind, locate 3 pi over 2 on your unit circle. 270. So we know that 3 pi over 2 is the same thing. Sine of 3 pi over 2 is the same thing as saying sine of 270. If I'm looking for the sine, what am I looking at? Your y. So what is the sine of 270? Negative 1. Do you see how we use the unit circle? Are you with me? Oh. Yeah? You're right. Oh, man, I've been sitting all day. All right. Now, negatives work a little different. You're going to find the positive and then reflect. Okay? So I'm going to go back to my unit circle thing really quick. Where's my unit circle? So if I was looking for negative 4 pi over 3, I'm going to find positive 4 pi over 3. Positive 4 pi over 3 is in quadrant 3, right here at 240. Do we see that? To find negative, you're going to reflect it over the x-axis. So negative 4 pi over 3 is going to be 2 pi over 3. Does that make sense? Okay, you find the positive and you reflect it. Find the positive and you reflect it. Yes? Okay, so if I'm looking for this, what was it? Cosine? The cosine of 4 pi over 3, negative 4 pi over 3, I reflect it. So I'm now looking for the cosine of 2 pi over 3 or the cosine of 120. Cosine is what again? X. And what is the x coordinate at 120? Negative 1/2. Yeah. Yes. So the other option is the long way, in my opinion. The long way is to find your, to multiply, change it, and then find 60 and do the opposite, taking it back to quadrant 1. So finding your reference angle and applying the negative of it. Which way was easier to you? I say positive reflect. In my opinion. Do you have to do it that way? No, but this is the mathematical way of doing it. Okay, so with the math, you would go through, multiply.
So if we can't have a unit circle,
You have to have it memorized.
so like, we, I don't know, right? Or are you gonna give us like a blank of this?
You'll have a blank one. All right. Okay, that's it for 3.1. All right, so 3.2, applications of radian measures. Okay. We are looking at the arc length on a circle and the area of a sector. These are two formulas that we will be utilizing. Okay. Arc length of a circle and area of a sector of a circle. Okay, so up first is our arc length formula. Our arc length formula is S equals R times theta. S equals R times theta. S equals R times theta. I know you see me highlighting.
S equals all the times theta.
Yeah, and for some reason my thing isn't highlighting. I don't know why. Cool. I didn't want you to really highlight anyway. Okay, I did, but
The new computer?
yeah, for some reason my new computer will read my writing board sometimes, and sometimes like, nah, you can't do that. Like first and second period I had no problem. But now it's just like, you don't want to learn it. All right, so S equals R times theta. What do you notice here about theta? Theta must be in radians, okay? For all formulas in trig, typically your theta has to be in radians, which is why we have to be able to convert from degrees to radians. Got it? All right, just friendly reminder, how do we convert from degrees to radians? There we go. Just flip it. Flip it. Pi over 1/8.
See?
All right. Again, it must be in radians. Okay. All right. So here we go. It says a circle has a radius of 18 and 2/10 centimeters. Find the length of the arc intercepted by a central angle with the measure 3 pi 8 radians. Do we have a formula for that? Oh my God. S equals what? R theta. Do we have our R? Do we have our theta in radians? So all I'm doing is what? Multiplying, plugging in. Since this thing won't let me use my pen, I'm glad that I left minimal writing to myself today. Okay, so we're using S equals R times theta. We're going to plug everything in. And then you just multiply. I put that all in the calculator. Okay, the only time you're not putting in the calculator if it says in terms of pi. Does that make sense? That just means that you're not putting it in the calculator. And since it doesn't say in terms of pi, we just plug all of this in. Do I need to model plugging this into the calculator? Exactly how it is.
So if it were to ask for in terms of pi, would you keep it like that? Or would you,
You would put everything in but pi
and then just add
at the pi in the end.
last? Okay.
Usually if it says in terms of pi, it should be numbers you can multiply with. All right. Basic use of the formula. How do we feel? Pretty good? All right. Now, just making sure. Let's take it up a notch. What happens here? I have the same radius, but I have an angle of 144 degrees. Before I do anything, I have to do what? Convert to radians. How do I convert 144? I'm going to do pi over 180. I'm going to take 144 and times it by pi over 180. You want your radians to be exact. Now am I good to use the formula? Well, yes, I am. I have my radius. I now have my angle in radians. And I plug it all in and we get.
Did you? Oh. Oh. So,
I'm listening.
how do you put that?
Which part?
142. Do you input, do you use a five?
So if you're gonna do it in the calculator, I hate when it does this. Sometimes Sylvie resets herself. So if I'm putting this in the calculator to radians, I'm not putting the pi in. I'm just doing 144 divided by 180. It's gonna give me a decimal, but I don't want a decimal, I want a fraction.
Because when did you do one?
What do you mean? Remember when you're multiplying, it's numerator times numerator, denominator times denominator. So it'll be 144 pi over 180. I'm not putting pi in the calculator, I'm just putting the numbers. So that's how it would be 4 pi over 5. I also could just divide both by 12 and then keep going down from there if I wanted to. Okay. And then now I have my 4 pi over 4, then my 4/5, and I'm just going to put in times 18.2 times pi. And I get my answer. Okay. All right. Now we're going to talk about how this is useful and how it was used before we had GPS and things of that nature to approximate the distance between two cities. Okay. So it says here, latitude gives the measure of a central angle with vertex at Earth's center. Okay. Whose initial side goes through the equator and whose terminal side goes through the given location. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north. Okay. And that of Los Angeles is 34 degrees north. The radius of Earth is about 6,400 kilometers. All right. That's going to be the radius you use every single time you're trying to find the distance between two cities. Does that make sense? All right. That's never going to change. Find the north-south distance between the two cities. So we're going to draw it out. We're going to look at Earth as a circle. And we know that Reno from the equator is 40 degrees. We know that Los Angeles from the equator is 34 degrees. So the distance between the two is going to be 6 degrees. Does that make sense? So the distance between the two cities is 6 degrees. So the distance from Los Angeles to the equator, latitude wise, is 34 degrees.
Okay.
And then 40. So the distance between these two has to be the difference between that, right? And we want to find their distance. So we're finding their arc length, their approximate kilometers from each other. Does that make sense? In order to do that, I have to convert my degrees first, right? So we're going to convert 6 degrees. So when I convert 6 degrees, it becomes pi over 30. Now, what did it say we're going to use for the radius of the Earth? 6,400 kilometers, okay? The radius of the Earth is 6,400. So I'm going to use the arc length formula. S equals R times theta. Our radius is always going to be 6,400. Our degree in radians is pi over 30. So they're approximately 660 kilometers apart. So what I like to do here is to actually go to the Google map and test it out to see how close you were. How do we feel about estimating distance using arc length? So step one, when estimating, is you're subtracting the degrees, right? Is that good? So step one, we subtract the degrees, the orange, After she was like, "What's that?" I said, "You filled an orange." It's just really strong. No, you're fine. We subtract the degrees, yes. After we subtract the degrees, we convert them to radians. After we convert to radians, we plug into the formula. And then we have our approximate distance. Agreed? Easy enough? All right.
Do we have to make
Mm. The radius of Earth?
Yeah.
Maybe. 64. What was she saying? What'd you say? 6,400. 64. 6,400. Say it 7 times and you'll remember it. That's are you counting? Okay.
That don't work.
It does. Okay. So it's approximately 670 kilometers. All right, we don't have time to do it, but that's what we're oh darn. To do the Google map.
Oh, I thought you meant the.
No, we're gonna do example 3. We don't have time to do the Google map. All right, here we go. A rope is being wound around a drum with a radius of 8,725 10,000 feet. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? Okay, so what do we do? What do we gotta do first? Okay, so the first thing we gotta do is convert. Now, if you want to just save it, you can just type it all in at once. At this point, we should be able to just, if you're using a calculator, use the calculator to the best of our abilities. Does that make sense?
Can you go back to the picture real quick?
Yep.
Draw that.
You're circling. Okay, so the goal is now on our third example, we should be comfortable inputting it all in the calculator at once, realizing that yes, step by step is great, but now to be efficient and to show that we understand what's taking place, we should be able to like kind of put it all in at once. If I know that I'm given the angle in degrees, I know that it's going to have to be converted, right? So naturally, this pen will not let me write, guys. I really just want to write, and it won't let me. It's letting me. So naturally, what ends up happening is I make a note to myself. If I'm given degrees, I end up writing that S equals R times theta pi over 180. And that's for if I'm given degrees, I'm just going to end up typing that all in, right? Because I'm going to have to convert the theta anyway. Does that make sense? Now, if it's radians, I don't need the pi over 180. But I have everything I need. I have my radius. I have my angle. So now I'm just going to plug each piece in and then plug it into the calculator. Okay, it's a real world situation. So we're going to want to know the exact value or approximate value. Not the exact. Thank you. All right, so we plug it all in. So when I plug it all into the calculator, it's going to tell me that it will be about 6,049 10,000 feet wounded at that point. I don't know when the pen started working. Could have warned me, could have told me it was working. How do we feel? Our theta for arc length is good to go. Anyone's like, oh no, I can't do that. If you're using a basic calculator, you multiply everything first and then divide by 180. So you would do 0.8725 times 39.72 times pi, and then divide by 1. If you're using a basic calculator, like on your phone. Yeah. All right. What happened? The gears? Not at all.
I don't know. How is the record? Like,
You don't write it all. Draw the picture.
yes, huh?
Draw 2 circles next to each other. A big one and a little one. All right, so we have 2 gears are adjusted so that the smaller gear drives the larger one. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? So this was a build on. So I'll let you draw your picture first, and then we will break it down. So you have a little circle and a big circle. And this one is rotating at 225 degrees. So what does this mean? The first thing we have to do is find the radian measure of the angle of rotation for the smaller gear. And then after that, we're going to find the arc length of the smaller one. Okay. And then the arc length there will be what we find for the larger one. So that's our plan. So we made a plan. First, find the radians of the measure. Okay. Second, we're going to find the arc length of the little one. And then we're going to keep going. Are we ready for our plan? Okay. So first you found, why did it all come at once? Are my animations off? Stop, what are you doing? All right, here we go. So radians, 225 is 5 pi over 4. Also comes from our unit circle. Then we're going to find the arc length. So we plug in and we're going to find the arc length. Notice this time, because it's not the end of the problem, but the middle of the problem, I kept it in exact form. So I kept it in terms of pi. In trig, especially, you want to avoid rounding into the very, very end. So for the little one, we know that this applies to this. Its arc length, because of its rotation, is going to be 25 pi 8 centimeters per second.
The 12.5 part, it should not make sense.
2.5 times 5. 2.5 times 5 is 12.5.
Okay, that's what.
Yeah.
And then you got 25 from that.
12.5 divided by 4.
Huh?
12.5 divided by 4.
That's what-
It's 25. All you did was, huh? It's 25 eighths. 12.5 divided by 4 equals 25 eighths.
I got
Why can't you just keep it as 12.5 pi?
A decimal within a fraction is a no-no.
Oh, okay, I see.
Did you convert it to a fraction? Did it give you 25 eighths? Okay. Math logic reason why is you just doubled that, right? I doubled this to make it not a fraction, but to make it not a decimal. So if I double the numerator, I have to do what to the denominator? Double it. But if you type it in the calculator and hit fraction, it's going to tell you 25 eighths. All right, our next step. An arc with the length of the larger gear corresponds to an angle measure of a certain. So this corresponds to the same thing, except now we got to find that angle. Does that make sense? Why is it all coming at once? It's supposed to be pew, pew, pew. Not bam. That it's throwing all at once. Yeah, it's making me mad. My animations are not animating. So now we know the arc length because we found the arc length here, right? So this tells us our arc length for our big circle. But we don't know the theta for this circle. So we're looking for the theta of what's the degree that this is turning. See, we know it's radians, but we don't know its theta.
So 25 pi over 8 is the arc length for the small one and the big
They have, so if you have two things that are connected, they're rotating, their arc length is gonna be the same because it's covering the same distance. Yes, if they're connected, your arc length is gonna be the same.
So that would be divided.
So in order to find this, we divide by 4.8. So I'm gonna do it in the calculator how I got there. So in the calculator, I'm gonna put in parenthesis 25/8 divided by 4 8/10. And all I did was hit math, right, to get my 125/192. Notice that I put pi in. No pi was put in. That's why my final answer is with pi. Okay. So my exact measure of my angle in order for their arc lengths to be the same, to be rotated the same, this is the arc that the measure that the big circle has to be turning in at the same time. That's its angle it has to be in. Now, if you are a mechanic and you're telling someone how their gears are working together, are you going to tell them, well, it's moving at 125 pi over 192 radians? No, you're not. You're going to have to convert that to give them an approximate degree of how that rotation is taking place. So when I take this, I'm just going to grab it and I'm going to multiply by pi. Times pi. So I have that. I didn't want to do that again. Go back. And I'm going to multiply this times 180 over pi to get my degree. That is not a pi symbol. That is a pi symbol. So approximately, what is the rotation of the big guy? We get 117.2 degrees. So in order for their arc lengths to be the same, the big guy has to be moving at 117.2 degrees. So there's the exact, and then there's the approximate. The exact is probably what the engineer would put into the system, right? But when they're conveying and talking about it, they would use the approximate. Okay. And the reason why I think about this, if you have two gears and their arc length isn't the same, are they going to be turning correctly? No, they would have to logically be going the same distance. Otherwise, something is off, something is broken. Does that make sense? Now, clearly one is bigger than the other. So therefore, it's going to have to rotate a little bit more to match how fast that little one is going at its own little pace. Which leads us to oh, I did have it on there. Someone could have told me if y'all were looking at the notes that I did it. Me neither. I was like, did I not put 117 somewhere? But I didn't. I didn't have the points in here, but you get it. So our larger gear rotates through an angle of 117. So the major takeaway here is connected circles, connected gears, connected spinning, whether it's connected through gears, connected through a wire, their arc length has to be the same. Do we get that? That's our major takeaway. All right. Now we're going to talk about area of a sector. Think of it as a piece of pie. How much of the pie am I getting? Does that make sense? All right. Thankfully, someone created a formula for it. And here's your formula. The area of a sector equals 1/2 r squared theta, and theta must be what? In radians. Okay.
only did because I had to. Necessary to read.
Okay. Are we ready to use area of a sector? Well, did you write down the formula, Elise?
Yeah.
All right, then you're ready. All right, so again, make sure that you are in what? Radians. Here we go. So a center pivot irrigation system provides water to a sector shape field with the measures shown in the figure. So you're going to draw a little sector, a little slice of the pie, and label it. So our slice of the pie has a central angle of 15 degrees and a radius of 321 meters. And what's to define the area of the field? Can I? It's your radius. Yes.
Oh.
Because it's a slice of the pie, right? Okay. So now, before I do anything, I must convert 15 degrees to radians because the formula requires that your theta is in radians. Yes. So we're going to convert 15 degrees. How do I convert 15 degrees?
That
Pi over
times
180.
nine.
Pi over 180. There we go. So 15 times pi over 180. If you use the calculator, what do you not put in there? Pi. Okay. What do we get for 15 to convert it to radians? Okay. So we end up with pi over 12 radians. Am I ready now to plug it into the formula? Yes. So I'm going to plug it into the formula like so. 1/2 r squared times pi over 12.
Do 1/2 321 squared times 15 times pi over.
You can plug it in all at once if your heart told you to do so. Okay, but you know how like on your math lab, it'll ask you to convert and then it'll ask you to plug in. It'll ask you to do it in little pieces, little big pieces.
So what we do 1/2 times 321 squared times 12.
Divide by 12.
I thought we don't have
Yeah, but 12 is in the denominator, so that's division.
180.
And we divide it by 12. We divide by 180.
Did we?
You're either going to divide by 180 or multiply by 1 over 180. However you want to think about it. But
Oh, I could have done 1 over 180.
Yeah.
That's why I'm asking you. You said no.
when did you ask me that?
Bro, I said, why are we just, why are we dividing by 180? Because I thought if we cancel out, I can just add 1.
So I didn't know what that meant. That
So
mathematically
the
didn't
pi
make
over 180 is 1 over 1.
Yeah, it's just 1 over 180 times pi. Remember, your numerator represents multiplication. Your denominator represents division. All right. So we plug that in and we get approximately the area of her field, 13,500. That's all for area of sector. I really didn't have more to tell you.
That's great. I'm proud of it.
That's all I have. Do you have any questions about area of sector?
No, that was pretty big.
It's pretty
It's
straightforward.
not like a gear thing. I'm good.
It's pretty straightforward. The gear thing you just got to remember is that the arc length of whether they give you the big one or the little one has to equal.
Yeah, but since I don't have a note card, I'm not gonna.
You tell your brain.
Do we have to remember this for?
No, it'll be on the board. Arc length and area of sector will be on the board for your test. All right. Are we done? Yes. Are we good?